Hello Thecloudsguru. Welcome to our next video on testing IPv6 connectivity. At the end of this video, you will learn lab preparations in routing IPv6 on your network address. So let's begin. Hello. We will create VPC IPv6 only using CloudFormation template and two separate template to create EC2 testing instances and Bastion host, and then test connectivity between instances with multiple configuration scenarios. Our VPC will have public IPv6 only subnet A in AZA with default route to Internet Gateway. Public IPv6 only subnet B in AZB with default route to Internet Gateway. Private IPv6 only subnet A in AZA with local routes. Private IPv6 only subnet B in AZB with local routes. I created hybrid IPv4 and IPv6 subnet C for our Bastion host in AZB. CloudFormation template include creation Internet Gateway. Route tables per subnets. Network access list for public subnets. Private subnets. And separate network access list for Bastion host in private subnet. Second CloudFormation template create Bastion host in hybrid subnets because of IPv6 endpoints limitation for SSM. Third template create 3 EC2 testing instances. First instance is in public subnet A. Second instance is in private subnet A. Third instance is in private subnet B. After creation our testing infrastructure, we will use Session Manager to connect to Bastion host, then from Bastion host we establish SSH connection to each node. First testing will check connectivity between all instances. From test instance 2, I will ping to test instance 1 and 3. Now for our step 3. Include establish SSH session to test instance 1. Then ping to the internet using IPv6 address. Moving on to our step 4. Include establish SSH session to test instance 2. Then try to ping to the internet using IPv6 address. And after unsuccessful attempt, we will add to route table default route pointing to Internet Gateway for private subnet A and B. And then ping again to the internet from test host. This step also include ping to the test instance 2 from the internet. We are now at step 5. That shows after changing default route from Internet Gateway to egress only Internet Gateway, we can ping to the internet from test host 2 without any problems. Now after which, lastly, we have step 6 showing connectivity from the internet to test instance 2 in private subnet A, after changing the default route in the route table. We can't reach test instance 2 from the internet. Now, let's start our demo. We are using CloudFormation to deploy network infrastructure. First, I will focus on resource section. And we have section setting up VPC. Section serving up IPv6 CIDR block. And VPC flow logs. Next one is setting up Internet Gateway and VPC Gateway attachment. Next egress only Internet Gateway. Then followed by section in which we create IPv6 only 4 subnets. Subnets A public is where we specify availability zone using the intrinsic function select, and the intrinsic function getAzs returns an array that lists availability zones for a specified region in alphabetical order. IPv6 CIDR block is using the intrinsic function CIDR, while IPv6 native parameter to true and then tags part. Subnets A private is done the same way with public, we specify the availability zone, then IPv6 correct CEDAR block, and lastly IPv6 native parameter to true. Same goes for subnets in AZB. Subnet B public is done the same way. We specify availability zone, IPv6 correct CEDAR block, then IPv6 native parameter to true. Subnets B private is done the same way with public. We specify the availability zone, then IPv6 correct CEDAR block, and lastly IPv6 native parameter to true. Last subnet is private subnet C in AZB. Here we will set Bastion host. So the configuration steps are: first, specify availability zone. Next, IPv4 correct CEDAR block. Then IPv6 correct CEDAR block. We are setting up route table in next section for route table for public subnet A, private subnet A, public subnet B, private subnet B, and private subnet C. The next section associates route table to the subnet. We specify table entries and associate them respectively. Default IPv6 route destination IPv6 CEDAR block /0, pointing to gateway ID of Internet Gateway. Next section is setting up network access list for public subnets, private subnets. I specify network access list private B, for special purpose of Bastion host private subnet C. Network access list entries codified by me and reference to public network ACL. Allow in and out any IPv6 traffic. Exactly same entries for private subnets. Network ACL function in AWS is to stop unwanted traffic. Security group function is to allow selected traffic. Last resource section associates network access list with the subnets. First, network ACL public is associated with public subnet A, public subnet B. Then, network ACL private is associated with private subnet A, private subnet B. Lastly, network ACL private B is associated with private subnet C. Last section of CloudFormation is output section. Outputs enable you to get access to information about resources within a stack. Output values can be imported into other stacks in our scenario application stacks. These are known as cross-stack references. We export VPC ID on the top of output section, and for each subnet, subnet's ID, route table ID, and VPC IPv6 subnet CEDAR block. Last output section represents VPC IPv6 CEDAR block. So that makes it CEDAR block association and IPv4 CEDAR block. Let's deploy CloudFormation template. To do this we need to open AWS console and be in correct region. In my case, it is EU West 2, London region. First, we need to jump to S3 UI section. Find file with correct VPC template with YAML extension. As you can see, I created number of VPC template stacks. Those high number of VPC stacks because of reasons. One is I keep many variations of same template, and second is some issue with AWS CloudFormation caching information during execution. It happens when you want to quickly deploy stack again with same file name, but after some correction in the template. CloudFormation see old version of template, not new after correction. To bypass it I change source stack file. I am selecting correct template to deploy VPC stack, then checking object properties. I copied object URL by clicking on a small copy icon before URL display. Then I open AWS CloudFormation section in a new window. That section has main default window as no CloudFormation stack deployed in London region. Click Create Stack, and we are ready to paste CloudFormation YAML object URL to dedicated tab. Then click Next. For step 2, we need to fill out empty sections. As we see, I provided stack name. All other places were filled up automatically as I put in CloudFormation parameter section default values. Then click Next. Moving on to step 3, configure stack option, and I will keep as default. Then step 4, review CloudFormation deployment parameters and then click Submit button. Now deployment starts. We are in an Event tab, and I will refresh Events window. We can see those resources in progress status. It takes a few minutes to deploy VPC stack. After refreshing Events window, we can see more resources in progress and some of them in a complete status. So we have in a complete status as Internet Gateway and VPC flow logs in green color, and of course more resources in progress status showing in blue color. Red on the other hand will indicate if resource fails to deploy. Let's wait to the end of CloudFormation deployment. More resources deployed. And done. Logical ID of our stack is in complete state. Let's change tab window to stack info, another place to verify stack status. VPC section that we created new VPC, Thecloudsguru VPC, with IPv4 CEDAR block 10.0.0.0/16 and IPv6 CEDAR block as you can see on the screen. Default VPC column indicated that we created that VPC. Details section show more information. CEDAR tab show CEDAR block status and who provide pool of IPv4 and IPv6 CEDAR addresses. Flow logs window shows detail of VPC flow logs that include destination, very useful link. Tags section shows us all VPC tags which has been programmatically specified in CloudFormation. Let's jump to subnet subsection. You can find it on the left AWS VPC console navigation pane section. We can see all subnets in London region. To filter subnets associated with other CloudSguru VPC, I copied VPC ID and pasted it in search subnet section. And there you go. We display interesting us subnets. Let's see configured parameters for each new created subnet. Public A subnet details. We have flow logs tab with easy to find destination URL. Next, route table tab shows us all route entries. We specify in CloudFormation template default route pointed to Internet Gateway. And local route added by default. Network ACL tab shows us that we configured in and out entry number 99 allowing all IPv6 traffic. Tags tab as we specify in CloudFormation template. Public B subnet details is the same, except IPv6 CEDAR block associated with subnet. So we have flow logs tab, next route table tab, then network ACL tab, and tags tab provides same information. Let's see a private subnets details. What I want to highlight is the route table and the creation for private subnets we have just for local route entries. Network ACL allow all IPv6 traffic in and out. As we expect subnets be private has similar parameters. Last subnet to examine is subnet C private. Route table tab show us just local traffic entries. and Network ACL allow IPv6 local traffic and IPv4 local VPC traffic. IPv4 entry is very important to put it in, as we need to establish session manager connection to Bastion host using VPC endpoints. At the moment of testing VPC endpoints not supporting IPv6, that's the reason private subnet C is in IPv6 and IPv4 hybrid configuration. I created and deployed CloudFormation application stack creating Bastion host infrastructure. As we can see in the Events tab, CloudFormation stack created VPC endpoint, then security groups for endpoints and Bastion host, and AWS Linux EC2 instance representing our Bastion host. Also, I located instance in private dual stack. We can see all related resources in resource section. I've opened instances on the left of our navigation menu in AWS Management Console. This is a new EC2 experience in AWS window, and we can find our Bastion host network properties in the Networking tab. EC2 instance has IPv4 address with 10.0.0.10 and IPv6 address highlighted on the screen. I will keep on the screen that address. Also, we can see that this is T3.micro instance type, minimum size to support IPv6 address space. Security tab section shows us that security group associate with instance, and which traffic ingress and egress is allowed to. We permit inbound IPv6 traffic on port 80, and all ICMP protocol with source:/0. In outbound traffic, we allow VPC IPv4 CEDAR range 10.0.0.0/16 meaning local traffic and all IPv6 traffic. I copied VPC ID to clipboard to paste in search subnet section and can easily find all interesting subnets. So I am now looking for private subnet C. And there you go. Double check route table associate with the subnet. Yes, we route just local IPv6 and IPv4 traffic. Let's now check Network ACL section. We have allowed any local traffic in and out. So that means we don't have any possibility that Bastion host can communicate with the internet. To confirm that, let's connect to the instance. On the top we have Connect button. Click that. We highlight Session Manager tab and again press Connect. And we have now established connection to the Bastion host, using Session Manager, and that is the most secure way to get instance. Please remember, as I confirmed before, that there should be no internet connection allowed to establish management session. Let's verify IP addresses. Now we can verify that IPv4 and IPv6 address are correct. Let's ping to itself. It's working, we have now response. Now do IPv6 ping to the internet. And now not working as we expected. Please notice that DNS for IPv6 is working. Time to create application stack number 2. Stack will create 3 instances, one in public subnet A, second in private subnet A and the third one in private subnet B. First, go to S3 bucket window tab. Find interesting as an object and copy URL to clipboard. For step 2, go to CloudFormation tab window, click Create Stack button and fill out required fields. As we see, we need to paste URL of CloudFormation template YAML file. Next, provide stack name. All other fields are filled out automatically from the template as we specified during coding. Configure stack options and we have to leave it as it is. Step 4 is to review stack, and if everything is okay, click Submit button. Then there you go. Create in progress is ongoing. We need to monitor CloudFormation stack deployment by refreshing event screen. We can see resources in progress status as well. And more resources. In progress and now in a create complete status already. Stack was successfully created, as we can see from the last log event in Events tab. Let's go now to Instances section in a new EC2 experience. Then refresh window. Finally, we have now 4 instances. 3 new test instances and a Bastion host. New instances is now in initializing status check. Let's check new EC2 instance properties. We have IPv6 address only associated with the host, exactly what we planned. We can see that stack creation is in a create complete status and in green. That's good news. Double check resources list. We have created 3 instances and 3 security group now. Each instance has separate security group attached to it. In instance window, we can observe that all instances are in running state. Check network configuration for test instance number 1 in public subnet A. Yes. We have just that IPv6 address associated with the host. Now, check security. We allow all inbound that IPv6 ICMP traffic, all HTTP and SSH that IPv6 traffic, and all that IPv6 outbound traffic. Let's confirm configuration for test instance number 2 in private subnet A. Security groups have same configuration as host number 1. Same verification will go for instance number 3 in private subnet B. And yes, we have exactly same security configuration as instance number 1 and 2. For this video, I have showed you series of demonstration on IPv6 and how to deploy IPv6 network infrastructure using CloudFormation. Before I go, I wanted to share some overview for the next video, where you learn more on testing IPv6 connectivity scenarios on AWS IPv6 only network infrastructure. And there you go. It has been another journey in learning with us. Thank you so much for joining me, and I had a great time in this video. Looking forward to having you in the next to come. And I hope this has been very informative for you, and I'd like to thank you for watching. Don't forget to like, subscribe, and be sure to click the notification bell for you stay updated on my next video. See you next time, gurus.